I really don't like using substitution on these types of problems, but I'm going to show you one with substitution. So I'm going to solve this guy right here, substitution. So we're looking at a problem right now that has x, y, and z. And these problems can be a little bit of a pain, and they're tough, and you got to really keep track of things. All right. So with substitution, my first step, I'm just going to say my first step right here is to solve. We'll go ahead and say equation 1. We'll say equation 1 for y. We're going to solve it for y. So I'm going to take equation 1, and here it is. It is negative 2x plus y plus 3z equals 20. And it's pretty easy to solve for y. What I'm going to do is I'm going to add 2x to the other side. So let's go ahead and say 2x. We're going to subtract 3z from the other side. So we're going to say minus 3z. And we're going to keep that 20 over there, and I'm going to say I'm solved for y. All right. So here is the equation I've done. And I'm going to go ahead and let's put a little box over here. That is our first one. All right. We solved the first equation for y. All right. Now, what we're going to do is we're going to slowly substitute this equation that's now been solved for y into both the other equations. So I'm going to call step 2. All right. We'll say step 2 is to, we'll say substitute. I'm just going to use the word sub, and I'll say number 1 into number 2. So I'm going to take this and plug it in for this y right here. All right, so here we go. I'm going to say negative 3x plus 2 times, right, and I'm not putting that y in there. I'm going to put parentheses, plus z equals 21. And in the place of that y, I'm going to plug all of this. I'm going to say 2x minus 3z plus 20. You got to be super careful. I'll tell you what I'm super nervous about is making a mistake and wasting a bunch of time on this video. So let's make sure we're okay. Let's solve this as much as we can. We're going to say negative 3x. I distribute through. That gives me positive 4x. Keep distributing. Negative 6z, make it small if you can, keep distributing, plus 40 plus z, let's make sure we know that's a z equals 21. All right, so now we'll do all our combinations. It looks like this negative 3x and the 4x are going to combine, right? We're going to combine that to get what looks like an x, right? And then we're going to take this negative 6z and this z, and we'll combine that to make negative 5z. We'll say plus 40 equals 21. And I like this fact that this x is alone. So I'm going to take this x, I'm going to move everything over. I'm going to add 5z. I'm going to subtract 40. I'm going to add 5z and subtract 40. And I'm going to get this solved for x. I've got x is equal to 5z minus, that looks like a 19 to me. And I'm going to go ahead and I'm going to put that a little box so we can see our step here, right? And let's go ahead and we'll call that step 2. All right. So now we got an equation here that we simplified down. And look, now there's only 2 variables in. And not only that, but this is like ready to be substituted in. It's already solved for x, all right? So now I'm going to take that equation, and our next step is, we'll call it step 3. We're gonna substitute this first equation, all right, into the third equation. That's what we're doing. We're going to take this now and plug it into this guy right here. Again, we're going to sub it in for the y. So here we go. We're going to write 3x minus 2, and then instead of y, I'm going to plug that in. 2x minus 3z plus 20. Then we go plus 3z equals negative 9. Now, I don't have the neatest writing, but I like to make sure my z's are smaller so I can kind of tell what they are. It doesn't look like a 32, right? So here we go. If we keep going, we got 3x, and we're going to distribute that negative 2 in. That looks like negative 4x. Distribute again. That looks like positive 6z. Distribute again. Minus 40 plus 3z equals negative 9. And keep going. Looks like these x's combine to negative x, right? Looks like these z's, looks like a 6z and a 3z. That's going to make 9z. And if I go ahead and add 40 to both sides, which I can right now as well, right? I get equals to positive 31. And you know, for right now, I'm good with that. I'm gonna make sure that we can see this is step 3. And if you look, these guys are now only to the point where they have 2 variables. So now I can plug this x in over here. I can substitute again, which we're going to call step 4. We have these 2 modified equations that have been removed of a variable of y. So I'm going to let's call this, I don't know, let's name it. Let's call this equation 1, 2, 3. Well, that'll be still equation. Let's name this equation. I'm going to put a little, we'll put a 4 here, and we'll name this equation equation 5. Where's the other equation? 4, right? Into equation 5. So here we go. I'm going to write this equation without the x, so that's just a negative, right? Plus 9z equals 31. And in place of that x, I'm going to plug in 5z minus 19. There we go. So that went in place of that x over here. If I distribute through, I get negative 5z minus 19 plus 9z equals 31. We'll combine like terms. We got 4z minus 19 equals 31. Right? If we add 19, we're going to add 19 here. Plus 19. Alright. Alright, and it looks like what I'm going to get is, alright, we got 4z is equal to what? 40, 50? Alright. I feel like I might have made a mistake in there, and I'm not happy about it at all. Oh, I did, and I found that mistake. So I'm going to back up and I'm going to fix that mistake, rather than do this whole video again. When I distributed through, right, I forgot to do this plus sign right here. And the reason I found that mistake is because while I was doing it, I realized that this problem probably is going to have a whole number, and I was getting kind of an ugly fraction. So I should have distributed to the negative 5 and the negative 19, and luckily I found it so quick, so we can finish up. I subtract 19, here. I'm going to get 4z is equal to 12. If we divide by 4, I'm going to get z is equal to 3. So I'm going to go ahead and I know my z now. So what I can do is I can take this z and I can plug it. So I'm going to say substitute z equals 3 into, well, let's plug it into equation 4. So I'm going to plug it into equation 4, which is this equation. It looks kind of easy to plug in there. So z equals 3, and here we go. X equals 5 times 3 minus 19. So x equals 15 minus 19. So in this case, x equals negative 4. And I'm going to go ahead and box this. And now I have x, I have z. I'm going to go back to my first equation. Right, I got this guy. So I'm going to substitute x equals 3 and, oh, that's z equals 3. Z equals 3 and x equals negative 4 into equation, and we'll call it equation 1. It's kind of a modified one up here. So I'm going to say y equals 2 times my x. I'm pointing with this finger up here, which is negative 4. Right? Minus 3 times my z, which we have right here is 3, plus 20. So I got y equals, that looks like negative 8 minus 9 plus 20, which is negative 17 plus 20. So we got y is equal to 3 as well. So I have an ordered triple that we're going to write down. So my ordered triple, it would be x. So we're going to go ahead and say negative 4 comma y, which looks like a 3, comma z, which is a 3. I'm going to box that up, and we are done with the first equation, and I realize it's long.